In section 2, we covered introduction with topics Industry 4.0 and blockchain myths. Now in section 3, we will focus on blockchain overview and types of blockchain. So first, let's look at what is blockchain and a brief overview about the basics of blockchain. So as you are aware, blockchain is a disruptive technology which will change the way business will be transacted across the world in the coming few years. There has been a lot of hype about blockchain, and everywhere in business, whichever domains you talk about, everybody is talking about blockchain and how we can use it to make the systems and the businesses better. So let's see when blockchain was invented. It was invented by Satoshi Nakamoto, who developed Bitcoin in 2008. So basically, what is blockchain? A distributed ledger technology, like you have your ledger which is manually maintained in books. The same thing now is distributed, and it is stored on every machine where the DLT will be available in a digitized format. The basic idea about a DLT is to record transactions between two parties in a permanent way without needing to have any third party authentication. So, once the data is put into the DLT, it is available to everybody, but we need to take care as to how to store the data or the transactions between the two parties. Basically, the blockchain consists of blocks which are linked using hashing, hence the term blockchain. Basically, blockchain is tamper proof because it uses cryptographic algorithms and storage of transactions is done in the blocks. And because we are using cryptographic algorithms, the process of making or building a blockchain is secure, and the storage process is efficient, secure, and it also reduces the cost of transactions, because all the transactions which are stored in a decentralized fashion across all peers. Let's see how a blockchain works. So typically speaking, whenever a user A makes a request for a transaction, the transaction is represented as a block or multiple transactions within a block. Now once the transaction is represented, the data is put into the block. Now the block is ready for storage. Now the data which is put in the block is calculated using cryptographic hash, and the header will point to the earlier block. Now after hashing, this block is ready to be stored. Now the block is broadcasted to every party in the network. Suppose there are 5 nodes peers in the network who are storing this DLT blocks, then all the 5 nodes will have the broadcasted block. Now once the block is broadcasted to every party in the network, the network together with all the nodes will validate the transaction. If they all agree that this particular transaction is correct, then the new block of data will be created and added to the existing blockchain. Now the transaction is complete. That means the transaction now is available on every block on all the peers in the blockchain. Now let's take an example. Suppose that after 5, one more peer is added to the network, then all the blocks of the blockchain will also be stored on that network, and in the coming sessions, whenever new transactions are added, then even the 6th peer will be involved in doing the validation and the agreement. The process of agreeing or validating the transaction is called as consensus, which we will speak about in the later session. The adaptation for this image is given below. So this is how a blockchain would work. It looks very simple, but it's a little complex, because in the initial stage, once the transaction is identified, then after that it is transferred. So the point is, you need to have a network, you need to have the peers, you need to have a fixed set of peers, because you can't just send it to everybody and ask anybody to validate. So, after understanding how a blockchain works, next we will look at how a transaction is stored in a blockchain. So, the steps for transaction storage once a transaction is executed is first step is encryption. The transaction is added to the online ledger after hashing and cryptography. Now the second phase is validation, which I just spoke to you in the earlier slide. Transaction code is sent to all the peers in the network without compromising on the private information. And so because there is no private information is not transmitted, there is no need to have a central controlling authority. Once the transaction is confirmed and validated by all or several peers, depending on the consensus, it is stored in the ledger as a permanent and immutable record of the transaction. Now, once a transaction is added to the blockchain, it cannot be deleted. Hence, we say that once it is stored on the ledger, it is permanent and immutable record of the transaction. Now, once the transaction is finalized, now this copy is sent to every peer which is storing the ledger, and now we say that the transaction is complete. In case of a database, we talk about confirmation, and we say that once the block is confirmed, then it is stored in the database. The similar operation takes place here, but we call it as validation, consensus, and then copying on every peer. So this is how a transaction block is stored in the blockchain. Next, we will look at the basic essentials of a blockchain. So for example, what is the structure of every block? Every block stores the set of transactions, so it consists a pointer to the hash of the previous block. It will also consist of a merkle root from where we have initially started, that is the genesis block, a nonce value, and the list of transactions in that block. It is possible that if the transaction is small, multiple transactions can be built into a same block instead of having one block per transaction, otherwise the blockchain will become very long. The second important point is transactions and the cryptographic hashing of data. Every new transaction which is added in the blockchain will be cryptographically linked to the previous block, thus making it immutable. So if you want to search for the first block in the blockchain, you need to keep on searching from the pointer to the pointer, from the last block to the first block. So because if any one block is changed in between, the pointers will not tally, and hence we say that this data is immutable and secure. The transactions and the tamper-proof property. The merkle root is stored in every block, so any change in the block will affect the entire blockchain. So blockchain is tamper-proof since hashes of all the blocks need to be recalculated, which requires immense power. And even if you make a change with the new hashes in one blockchain, in one peer, you can't make the same change in all the peers because everybody will have to validate it. So blockchain is tamper-proof. Now validation and consensus. All the peer nodes need to validate and agree on including a new block in the blockchain as per the pre-decided consensus mechanism. The types of blockchains. We will look at both of them a little later, that is permissionless and permissioned blockchain. They are also called as public blockchain and private blockchain. Next, we will look at a few characteristics of the blockchain. Now, as you are aware, there is a lot of industry use cases which have been emerging around blockchain, whether it is in the public sector or in the private sector, and all of them want to store the data selectively and securely with others, exchange data, and then even carry out digital contracts. So, what are the characteristics of blockchain which will help the businesses to do these functions? So basically, the blockchain is a shared distributed ledger storing the most updated transactions. It is supported by a P2P network. It could be public or private. So there is no single point of failure, because if a few peers fail, you can retrieve the blockchain data from the remaining peers. Also, no one can make any modifications to the transactions once they are stored on the blockchain, and each peer member needs to use the same consensus mechanism to verify the transactions. You can't have different things happening in the system. Once the consensus mechanism and the validation process is defined, it is followed by all the peers in the blockchain. The another important characteristic of a blockchain is it enables a unique audit trail. Because you know who has stored the block, how it has originated, how it was validated, you can trail the blocks to the origin. So after looking at this characteristics of a blockchain, so who else can use a blockchain? So organizations and even individuals. Individuals can use a blockchain to manage their financial, medical, and legal records, and they may even, in the long run, be able to have no intermediaries in between, and they could have their own trust and reputation for their data. Now, let's look at a few examples where blockchain can be deployed or has been deployed. So, for example, Europe's largest shipping port, Rotterdam, has launched a research lab to explore the technology applications in logistics in the freight sector. We will be covering this in our use case of maritime sector. Utilities in North America and Europe are using blockchain to trade energy and manage billing at for electrical vehicle charging stations. Blockchain is also disrupting social media because users can get an opportunity to own and control their images and content. Blockchain consortiums, a group of organizations have come together and have their own consortiums, including the Enterprise Ethereum Alliance, Hyperledger Project, R3, B3I, are all developing an array of enterprise blockchain solutions. We will know more about these domains and how they can adopt blockchain technology for enhancing their businesses in the recordings to come. So, after looking at the characteristics of blockchain, we first initially spoke about what is blockchain, how it works, how a transaction is stored in the blockchain, the essential components of a blockchain and the properties, the characteristics of blockchain, a few live examples where blockchain is adopted, and this is where we conclude the blockchain overview session. In the next session, we will look at types of blockchain.